Last time we looked at the kinematic equations, we looked at problems that only dealt with constant velocity. Adding acceleration to the mix does not change how we deal with the kinematic equations, just that we should be looking for a new variable in our problems. The kinematic equations, they are equations that allow us to predict and calculate motion through a set of equations. They're derived from the relationships between position and time, derived from the relationship between velocity and time, and derived between the relationships of acceleration versus time, as we've seen in position, velocity, and acceleration versus time graphs. The variables that are involved in the kinematic equations are displacement, which is represented by an x, acceleration, which is represented by an a, time, which is represented by a t, final velocity, which is represented by a capital V, and initial velocity, which is represented by a v sub 0. That subscript means the initial or starting velocity when time is 0. The units that go with these variables help us to not only answer the question properly, but to pull the given information from the word problem scenarios. X, or displacement's unit, is meters. A, or acceleration's unit, is meters per second squared. T is in seconds. Time is in seconds. Both v and v sub 0, so final velocity and initial velocity, are in meters per second because they're both different velocities at different times. This is going to be the biggest change between initial and final velocities. We're going to see one higher than the other. The kinematic equations are listed below, as well are the variables that are not included. When you list out your given information, list out what variable you're being asked to find, you'll be left with one of the 5 variables that's not included. You're not looking for it, and it wasn't given to you. This is how we decide on the equation to use for each particular scenario. This can be done using a list of the kinematic equation derivations, so you can worry less about the math and worry more about the physics. Step 1. Find the variable that's not included in your scenario. Step 2. Select the derived equation based on the variable you're solving for. Notice there are 4 sets of equations. Next to each one of those has x is not included, v is not included, t is not included, or a is not included. Within each set, they have an equation with one variable by itself on the left side of the equal sign. If I'm solving for t, I'm going to find the equation that has t by itself. If I'm solving for a, I'm going to find the equation that has a by itself. Let's practice. So I have all of my variables here. I'm given 50 meters per second. I'm given 0 meters per second. I'm given 10 meters. I'm looking for A, because that's where my question mark is. So I'm looking for acceleration. T is not included. So I'm going to find my variable or my equations where T is not included. That's right there. That's that set of equations. I'm solving for A. So I'm going to find the equation that already has A by itself. It even says right there, if solving for A, ... use this equation. In this scenario, we're solving for final velocity. We have initial velocity. We're given time, and we're given acceleration. What's not included in this case is x, displacement. So I'm going to find the set of equations that says x is not included. I'm solving for final velocity, so I find the formula that has final velocity by itself. In this case, it happened to be one of the 4 original kinematic equations. The steps for solving a kinematic problem are no different than when we dealt with this for constant velocity. Step 1. List your given variables, including the units, to make sure they match up. We list the units because we want to make sure that if I put down that velocity is 5 seconds, I should catch it right away. I need to know my units so that I can pull those variables and those given pieces of information out of the word problem. If I'm looking for velocity, I need to look for meters per second in the word problem. Step 2. Figure out which variable the problem is asking you to solve for and which variable is not included in order to select the correct kinematic equation. The variable that I'm solving for or looking for is usually in the question. It may say how far, displacement, how long, time, how fast, initial or final velocity. Whichever variable of the 5, so I now have 3 givens, 1 that I'm looking for, whichever of those 5 is left over, that's the variable that's not included. Once you know which variable is not included and what we're solving for, you can properly select the kinematic equation that best fits this situation. Start your work, your actual calculations, by writing out the general form of the proper kinematic equation. The third step, substitute the given values into the equation, plug and chug. Because we're using derived versions of the kinematic equations, we don't have to solve. We can just use the order of operations to solve for the or evaluate for the unknown variable. Step 4, put the proper unit on the answer and check to see if it's reasonable. The unit is very important. If it says how fast, you better have meters per second. If it asks how long, you better have seconds. Make sure that the unit on the answer matches the question being asked. When we talk about how reasonable an answer is, this has to do sometimes with the magnitude. Does that value seem too big or too small based on what you know of that object's motion? Sometimes it has to do with the sign. Negative velocity means backwards. Negative acceleration can mean that it's moving backwards, speeding up, or slowing down forwards. Make sure that you have the proper sign that represents that particular motion. A couple tips for kinematics and acceleration. If the object is speeding up, the initial velocity, v sub 0, is smaller than v, or the final velocity. So if it's starting slow and then moving towards faster velocity, it's going to start with a smaller initial and end with a higher final. The opposite is true if you're slowing down. So if the object's slowing down, the final velocity is smaller than the initial velocity. So you start out faster than you end when you slow down. If a word problem ever says that an object is starting from stop, or it's at a stop sign and then speeds up, the initial velocity is 0 meters per second. That means it starts at 0, starts at stop. If it's coming to a stop or coming up to a stop sign or stoplight, that means the final velocity is 0 meters per second. It ends at 0. It ends at stop. Let's try an example problem together. A car speeds up from being stopped at a stoplight with an acceleration of 5 meters per second squared. It reaches a top speed in 38 seconds. How far does the car travel in this time? Well, we see that it's starting at a stoplight. It's starting from stop, and then it'll eventually go faster. So my initial velocity is 0. This value is not given to us. It's not identified as velocity. Remember, when you are starting from stop, your initial is 0. When you're coming to a stop, your final is 0. They tell us that acceleration is 5 meters per second squared. We also see that meters per second squared is the unit of acceleration. There's two ways that we know that 5 meters per second squared is the acceleration for this situation. 38 seconds, that is time. Time is in seconds. It didn't tell us this is the time, but I had to know that because the unit seconds represents time, 38 seconds goes next to t. Next, I need to look at what variable is unknown, or the variable I need to solve for, and then which variable is going to be not included. Remember, of the 3 givens, the one unknown variable, the variable that's left out, that is left by itself, that's not included. So how far does the car travel in this time? How far is a question of displacement. So I'm going to put a question mark next to x. So I have 3 givens, one unknown, or one that I'm solving for, and then one variable left over. The final velocity is not included. Now that we have all of this information collected, we can find a proper kinematic equation. V, or final velocity, is not included, so I'm going to go up to that set of equations. One of those three is going to be the proper version that I'm going to use to calculate for displacement. I'm trying to find displacement, so I need to find x by itself. There's the proper equation. Write that equation out in full general form. This will help guide you where to put all of the variables when you calculate. I'm going to replace all of my variables with parentheses, and in the parentheses I'll plug the values that they represent. A equals 5 meters per second squared. T equals 38 seconds. B sub 0 equals 0 meters per second. T equals 38 seconds. All the values go in place of the variables. We're substituting in. Now we can follow the order of operations. We're going to plug and chug. 0 times anything goes away, so the end of the equation drops out. I'm going to do 38 squared to give me 1,444. 1/2 times 5 gives me 2.5. 2.5 times 1,444 gives me 3,610. The last step of solving a kinematic equation problem is to include a unit. I'm solving for displacement, so displacement is in meters. Having your variable that you're solving for and the unit of your final answer match up is a very important step. It shows whether you're just throwing numbers into a calculator or if you're understanding what the values that you're representing equal. With this much work, always make sure to circle or box your answer.